All right, folks, welcome back to Precalculus, Chapter 6, Section 5, Inverse Trig Functions, which is just a glorified review of Chapter 5, Section 6, where we really dove into those inverse trig functions. So I would strongly suggest taking out the Chapter 5, Section 6 notes to review inverses a little bit. And you're going to see that as we begin, okay, because we're actually going to start on the back, and we're going to start by sketching a graph of each of the inverse functions. So the first graph that we are going to sketch the inverse of is arcsine. Okay, without going through the proof, which we did in Chapter 5, Section 6, in too much depth, we recall that when we inverted our sine function, restricted the domain, and thus restricted the range, it affected the domain and range of our inverse. So it made our inverse have a domain of -1 to 1 and a range of -pi halves to pi halves. Should make sense. Arcsine only outputs angles into quadrants 1 and 4, -pi halves to pi halves. The arcsine of -1 is -pi halves because the sine of -pi halves is -1. The arcsine of 0 is 0 because the sine of 0 is 0. And the arcsine of 1 is pi halves because the sine of pi halves is 1. And if we draw our graph, it'll look something similar to that. So moving on, we'll do arc cosines the same fashion. We restricted the domain and range of the cosine function to make it pass the horizontal line test, etc., etc. And it gave us a domain of -1 to 1 and a range of 0 to pi. And I'm going to go ahead and throw pi halves in the middle there because we're going to have a critical point there. The arc cosine of 1 is 0 because the cosine of 0 is 1. The arc cosine of 0 is pi halves because the cosine of pi halves is 0, and the arc cosine of -1 is pi because the cosine of pi is -1. And if we draw our graph, it looks something similar to that. Okay. Lastly, arc tangent, same thing. We restricted domain and range of the tangent function, make it pass the horizontal line test, etc., etc. And what it did was it gave us a infinite, an all real number domain, and a range from -pi halves to pi halves, quadrants 1 and 4. Okay, it made our vertical asymptotes into horizontal asymptotes, and our graph looks similar to this. Okay, beautiful. So we can review, and we can fill in our table at the top as well. So the domain, again, to recall, arcsine is -1 to 1 inclusive, with a range of -pi halves to pi halves inclusive. Okay, arc cosines, same domain, -1 to 1 inclusive, with a range in quadrants 1 and 2, so 0 to pi inclusive. And the arctangent domain was -infinity to infinity, all real numbers, with a range of -pi halves to pi halves, uninclusive, because that's where we had our horizontal asymptotes. Okay, so diving right in into some examples. We've got a whole bunch of examples. We're going to go really quick. If you have your unit circle handy, it's going to help you tenfold. So the arcsine of radical 3 over 2. What angle on our unit circle in quadrants 1 or 4 has a sine value of radical 3 over 2? That's going to be, 60 degrees, or pi thirds radians. Okay, here we try to take the arcsine of 3, but you can't take the arcsine of 3 because 3 is outside of the domain, -1 to 1, so this is undefined. Impossible. The arcsine of 7/8. 7/8 is in the domain of -1 to 1. Okay, however, it is not a value that is special on one of our special triangles on the unit circle, so we're going to have to use our calculator. So we'll turn our calculator on. I'm going to go ahead and just give the answer in degrees, so I'm going to press the mode button, scroll down, and choose degree. And I'm going to take the arcsine of 7/8 and get 61.04 degrees. Beautiful. All right, the arc sine of negative radical 2 over 2. What angles in quadrants 1 or 4 have a sine value of negative radical 2 over 2? That's going to be negative pi fourths. You might be tempted to say 7 pi fourths, but remember 7 pi fourths is outside of the range of arc sine. Okay, so now jumping into some arc cosine. What angles in quadrants 1 or 2 have a cosine value of negative 1/2? That's going to be 120 degrees or 2 pi thirds radians, same thing. Okay, the arc cosine of 0. So what angles have a cosine value of 0 in quadrants 1 or 2? That's going to be 90 degrees or pi halves. Here again, another value that we're taking the arc cosine of that is not on our unit circle, or it is on the unit circle, but it is not necessarily a special angle. So we're going to have to use our handy dandy calculator again. So I'm going to take the arc cosine of radical 6 minus 1 divided by 5. Oops. Sorry, did not mean to hit the graph there. Looks like we're going to see a picture of whatever I had graphed on my calculator for a quick second. And done. Let's get back here, take the arc cosine of radical 6 minus 1, all divided by 5, and we're going to get 73.15 degrees. Okay. The next question says arc cosine of 5/4, but we know that the arc cosine of 5/4 is outside of the domain. 5/4 is bigger than 1, so this is going to be undefined. We can even take a look at it on the calculator really quick. Arc cosine of 5/4. And you see our calculator says error domain. Okay, moving forward, arc tangent of radical 3 over 3. So what tangent values in quadrants 1 or 4 have a tangent, or what angles in quadrants 1 or 4 have a tangent value of radical 3 over 3? That's easy. That's going to be 30 degrees or pi 6. 30 degrees has the most 3's. The arc tangent of 90, okay? 90 is just a very large number. It is not necessarily a ratio on our unit circle, so we're going to have to pull out our calculator again and do the arc tangent of 90, and we get 89.36 degrees. The calculator's in degree mode right now. The arc tangent of 0, what angles in quadrants 1 or 4 have a tangent value of 0? It's easy, that's 0 degrees or 0 radians. Either one, same thing. And which angles in quadrants 1 or 4 have a tangent value of negative radical 3? That's going to be negative 60 degrees or negative pi thirds. Beautiful. So we're flipping over. We've got a couple examples left here. We're given a triangle ABC where the side lengths of A and B are 3 and 4 respectively, and angle C is 90. So we know we have a 90-degree triangle, which means we can use SOHCAHTOA. I'm going to call that C. Doesn't matter what I call A and B, but that would be a 3, that would be a 4. Pythagoras would tell us that that's a 5, and we want to find the measure of angles A and B. Well, to find, let's just say I want to find B, I'm going to take the arc tangent of opposite over adjacent 4/3 will give me B. So the arc tangent of 4/3 is 53.13 degrees. If I subtract that from 90, I know that now my angle A has to be 36.86 or 87 degrees. And I'm done. Okay. The next question is done the exact same. I'd like for you to complete it as part of your notes. But that concludes Chapter 6, Section 5 for now. Thank you. Have a good day.